For the last, we have the asymptote. So asymptote is the boundary in the graph of rational function. So it is the line that a curve approaches at its head towards infinity. So we have an illustrations here. We have illustrations for the vertical asymptote and the horizontal asymptote. So this is a curve, and this is your vertical asymptote, or denoted as C, and this is the curve or the rational function, and this is our horizontal asymptote, the V. Now, let's define what is these vertical and horizontal asymptotes. First, vertical asymptotes. So, these are the restrictions on the x values of x of a reduced rational function. So this restrictions again will make your function equal to be undefined. So again, this is the illustration for our vertical asymptote. So how can we get, or how can we find the vertical asymptote? So we need to find the vertical asymptotes. Equate your denominator on the rational function of the rational function to 0. So it can be denoted by this: d equals to 0. Then solve for the value of your x. So this value of x is the vertical asymptote. So again, equate your denominator. So the lowest part of your rational function, then solve the value of your x. So what is this horizontal asymptote? So it's a value on a y value on a graph which a function approaches but does not actually reach. So just like what the illustration says here. So this curve approaches the B, or your horizontal asymptote, but it does not actually reach or touches that asymptote. How can we find this horizontal asymptotes? So in here, we need to compare the degrees of our numerator, the polynomial in your numerator and in our denominator. So here is the form of the rational function. So we have here the numerator. So we have a sub n, x raised to n. So we have this first, the highest order plus a sub n minus 1. So in as descending order. So another one, we have here our denominator, which denotes the constants for your polynomial as b. So b sub m, x raised to m. Then m is the highest order of your polynomial in the denominator. So first, we need to compare the degrees again. So n and m. So if this n, this exponent or the degree, right, or the highest degree is less than 2m, so the highest degree in your denominator, the graph of this f of x has the line or horizontal asymptote y is equals to 0. So again, y is equals to 0. So if n again is less than 2m, so meaning you have a lesser, the highest degree, you have a higher degree in your denominator than in numerator, then we have y equals to 0 as a horizontal asymptote. Next, we have if n is equals to m, meaning the degree of your numerator is also the same with the degree of our denominator, meaning the graph of f, or the rational function, has the line y is equals to a sub n. So the coefficient of your highest degree in the numerator over b sub m, or the coefficient, numerical coefficient, or the value here beside your highest degree in the denominator. So we have a sub n, b sub m over b sub m as the horizontal asymptote. And last, if n is greater than m, meaning you have a higher degree in the numerator than in the denominator, meaning the graph of f of this function has no horizontal asymptote. Again, if the degree in your numerator is greater than to the degree of your denominator, so meaning that graph has no horizontal asymptote.
So let us have this example. We have used the previous given f of x equals to x squared plus x minus 2 all over x minus 3. So this time we have to find the vertical and horizontal asymptotes of this given rational function. So how can we get the vertical asymptote? So first, let's get the vertical asymptote. So in order to get your vertical asymptote, we need to equate our denominator, denoted by d, to 0. So in this rational function, here is the numerator. So we have x minus 2. So equate to 0, we have x minus 3 equals to 0. And we need to transpose your constant here to the other side to get the value of your x, which is x plus equals to 3. So here the x is equals to 3. So meaning this is the vertical asymptote, or the boundary or restriction of our rational function. What about the horizontal asymptote? So we had three conditions that we need to take a look if to get the horizontal asymptote. So here we need to know the degree of your numerator and the degree of the denominator. What do you mean by degree? The highest exponent or the highest order we have as in your polynomial in your numerator and denominator. So in our numerator we have the highest order, which is second order. So we have n is equals to 2. So in our denominator we have x only, so we have 1. So this n and m has a relationship n is greater than m. So this inequality satisfies our third condition, which is n is greater than m, wherein the horizontal wherein this concludes that we have no horizontal asymptote. So meaning there are no y. So now let us have another example. Find the vertical and horizontal asymptote of the given rational function f of x equals to x squared plus 6x plus 8 all over x squared minus x minus 6. So this rational equation or rational function rather is not yet already in its lowest form. So let's first find the factors to know if there are common in our numerator and denominator in order to simplify or get the lowest form. So we have f of x equals to x squared plus 6x plus 8. Just rewriting the given. So x squared minus x minus 6. So for our numerator, the factors of 8 can be 4 times 2 or 2 times 4. So we have 4 and 2. So x plus 4 and times x plus 2 all over the factors for our denominator, which are for negative 6, we have negative 3 and positive 2. So negative 3 times positive 2, that is negative 6. And negative 3 plus 2, that is negative 1, which is the coefficient in your second term. So we have x minus 3, and then x plus 2. So by taking a look at this factored form of our rational function, so are there any similar or common factors in our numerator and denominator? So yes, we have x plus 2 in our numerator and x minus plus 2 again in our denominator. So we can remove that by cancelling, because x plus 2 over x plus 2, that is equals to 1. Or we can, if we divide anything to itself, that is equals to 1. So now our simplified function, rational function, is f of x equals to x plus 4 over x minus 3. So let's now find the vertical asymptote. Again, let's just equate your denominator to equals to 0. So we have x minus 3 equals to 0. Then your x is equals to 3 by transposing your negative 3 to the right side, which is positive. So this now is your vertical asymptote. What about the horizontal? So for our horizontal asymptote, again, let's take a look at the degree of our rational function. So since your numerator has a degree, or your n is 2, second order, and your denominator again is also in second degree. So we have m is equals to 2. So your n is equals to m. Therefore, it satisfies the second condition. We have n is equals to m, then the graph function of the function of f, function of x has the line with, y is equals to a sub n over b sub m as your horizontal asymptote. So what is this a sub n and b sub n? So let's just substitute the value of the coefficient beside your highest degree. So we have 1 here to your x squared, to the numerator, also 1 here to the x beside the x squared of our denominator. So we have 1 over 1. So our y, or horizontal asymptote, is equals to 1. So that's it for our vertical and horizontal asymptote.